Okay, you guys ready for some exciting stuff?
Mm-hmm.
I've given Gerd a preview already, so but Lainey, you can be impressed. So I was working this last week on some aggregation features. So let me give I'll kind of a talk as I demo this. So here I have a directory and I have some files. We have a file called tall.h5, so your ordinary HDF file. And we have a folder on HSDS. I'll call this. Oops, what did I do? My first mistake. So empty folder. And of course, I can do hsload, tall.h5, home John ctd. And now I've basically sharded this HDF file into the HSDS representation, and it's on the server. And if I do HSLS versus H5LS, we can see the contents like so. Should we are. So pretty good stuff, right? And this is all what we had before. Now there is a append option to hsload. And there's 3 different types of appending or aggregation that can happen. The first is if we have another file that doesn't share any common paths with the first file. So I have a file g3.h5, and if I look at that, it looks like this. So we have a file with a subgroup, and the subgroup has a data set. And we can do, if I just do hsload g3.h5 to home John ctd to all.h5, this would overwrite the existing domain on the server. But if I add this -a option, it's append mode. So it will take this file and just kind of slide it in to the existing domain. And now if I list this contents, we see all the same stuff we had before, but now there is our G3 and G3/RAN3 dataset included. So this can be handy if, say, you have a set of HDF files, all with different groups, and you want to merge them together into one thing. Okay, but that's not all we can do. We can take the original file. So let's take tall.h5, use our -append mode. And what happens now that we do have existing HDF paths that conflict with the paths in the HSDS domain. Okay, well, something happened. If we look at this now, we see that what was a 10x10 data set has become a 2x10x10, and the 20 has become a 2x20. And here again, the 10 is 2x10, and we have a 3/5 became a 2/3/5. And if we add it yet again, oops, if we do another load and then list that. Now, similarly, we've added another dimension and so on. Right. So now we've done 4 loads, those same paths, and now we have an extra dimension, and every time we do another append, we're adding another layer in that first dimension to the data set. Okay, and notice this G3 RAN3 is still 3 by 3 because what I loaded didn't conflict with that G3 RAN3. So that's all pretty good. So this was useful with a NASA data set, and I actually ran this on HDF Lab. You can see the notebook is here. Yeah, I can put that in the chat. But if I just go to HDF Lab, let me clear this. So this is based upon a NASA data set that has 7,850 files. So this is pretty common in NASA, where every satellite orbit or whatever, every day, they are creating a file. And they do this for 7,850 days and wind up with a whole bunch of files. And that can be a little challenging to run analytics on and non-performant, because you have to open and close many, many HDF files to get some kind of summary results of this. So what we have is, I ran this hsload-a on these 7,850 files to create one aggregated file, which you can find in shared NASA NSEP3, NSEP3.at file. So let's look at this. So we open this, and we have 4 data sets in this subgroup. If I take one of these data sets, I see its dimensions are 7,850, 720 by 1440. So in the original files from NASA, the dimensions were 720 by 1440. But since we've appended 7,850 times, now we have a 3-dimensional data set where the first dimension is a time dimension, and the second 2 are these spatial dimensions. If you look at the chunks, we see we have basically cubic chunks. So it will be equally good or bad, regardless of what selection you're doing, whether you're searching through time or geospatial. And we list this here. We can see the attributes, the units. You'll notice the CPU time basically doesn't take any time for reading attributes, because when we first opened the file, the H5PyD downloaded all the attributes for all the data sets in the file. Okay, so now let's take let me change this up. So let's read the 2,435th slice of this data set. So we do that, and it took 1.17 seconds. If we read same thing again, it's 200 milliseconds, because the server cached the data from S3 on that first read. And even if we move that slightly, I think we'll still be in the same set of chunks, so it should still be relatively fast. And there you have it. So the min, max, and mean values. So the min is -999. The max is 30.67. I think this is water temperature. And that's pretty cold for the ocean. But remember, the fill value was -999. So anything that is a fill value, we should ignore. And that's what I do here with the plot. I set the Vmin to be 0 and the Vmax to be 30, because that's actually the relevant range that we're looking at. And we have a nice plot showing this variation in ocean temperature. And then I can zoom in on that. Nice. And now if I want to do some, create a histogram on the non-filled values, there's this interesting NumPy thing where we can say, select all the values from this NumPy array where the element value is not the fill value. And from that, we can create a histogram and plot that. And it looks like this. It looks like 0 is a common value. Okay, next, okay, and this is the thing that actually is hard to do with the original files that were day by day or hour by hour. We can take a time series by saying the start index to be 0, end index to be 7,850, that's our entire range, and some specific spot on the globe that we want to look at. So we do that. We get a result in 1.86 seconds, right? So I didn't time it, but that is likely substantially faster than if you had to open 7,150 files one by one to extract those values. And we can do a plot. Here we see like a seasonal variation of the temperature. And this one actually takes some time to run. Let me kick it off. Here we're creating a summary for each year. We're getting the data and looking at the mean, median, standard, max year by year. So that takes some time. Meanwhile, I mentioned there's 3 ways we can do aggregation. Here it comes. So here we have like the change in the mean temperature over the whole Earth for this 100 days going forward. So I mentioned there's 3 ways we can do aggregation. Third way is where we're not adding new data sets or groups, and we're not adding a new dimension. We're extending along an existing dimension. And the challenging part of that is determining which dimension should be extended along. Now, if we look at another data set, which I have up here.
Elena has a question.
Go ahead.
Yeah, John, I think it's very useful feature, and ladies here who created NEC tool. But here's my concern. You has to know really what they are doing, because as I recall, HDF EOS file, and you guys correct me if I'm wrong, it will come with for each data set for physical value, there will be data set with the geolocation for each point or for whatever data array. When you combine, are you combining them also some kind of intelligent way? Because your map will be incorrect.
Right. It depends what kind of data you have, right? So this data set, this NSEP3, didn't have dimension scales defined, right? So
it's not dimension scales. HDF EOS will have longitude, latitude, and some subdirectory, as I recall.
Right. But this particular file didn't have any of that, right?
Oh, okay. So, I think it will be extremely useful if it can be extended to EOS files and NPP files. With NPP files, there will be different structure, but they also, you have to recalculate some references to point. But yeah, it's very okay. Thank you.
Yeah, and so listen to this next part, and maybe that addresses, or maybe there's some other approach that I should be thinking about. But we're going to take as our starting point, I have 4 of these NetCDF files for the Grand Canary Islands, apparently, for 2016, 2017, 2018, and 2019. And these have data sets, lat, long, SST, time, WD, WS, high WD, high WS, south, north, west, east. So the time is just one-dimensional, right? And it's like days in a year. And this is actually a dimension scale that's used in this data set. Okay, so this is a primary data set where it's 4-dimensional. The shape is 8784 by 3 by 5 by 5. The 8784 relates to this time dimension. The 3 relates to this height dimension. The 5 and the 5 relate to lat and long. Okay, so with NetCDF, you open this and it's using the lat, long, time, and height as dimension scales for WD and WS. Okay, so if I'm going to do this appending thing, I don't want to do what I did before, where I add yet another dimension, say WD, right? I don't want to have like 4, 874, 3, 5, 5. What I want is to extend along the time dimension, right? This 8784. And the question is, which dimension should I be extending along? And how does HS load with the -A flag note that, right? So what we have is another option called HS load -A -- extend. And here you provide the dimension in which you want to extend along. So in this case, we want time. And you give the source file and your destination. So it's binary data. Okay, and now if we look at this, okay, so we didn't add any dimensions, and it looks pretty similar to what we have here, but if we do the -V option, we can see that, for example, the time now has a unlimited max dimension, right? So when this time data set was created on the server, we know that time is a dimension we're going to extend along. So we make this unlimited so that in future HS loads, we can add along that dimension. Similarly, in the WD data set and WS data set, you'll see that this first dimension has unlimited max extent. Okay, now we can do the same thing with the next file. And if we look at that, we see, let me go back. See, now we have time is 17544, and WD data set is 17544,355. And if we load the next two, oh, I only had 3 files here. Okay. Anyway, so now we see we have 26,304 elements along time dimension, and the WD and WS data sets correspondingly have that many extent along the time dimension. Okay, so this I'll agree requires some awareness, right, of how these data sets are set up. So it's more of a pro user feature, I guess. But I think if you are doing this, you'll have to explicitly use it, right? You're going to use this extend option only if you have files that fit this NetCDF model that would make sense to use it. And the other options of aggregation also, I think, are useful in different circumstances. Okay, so Elena, did that address your earlier question, or?
Yes, it does. So bottom line, users have to know what they're doing. But what I was saying, it is really would be useful because it will save a lot of headache if you have something similar to what NEG is doing aggregation for specific data products in the right way. And but that's it. So yeah, thanks.
Right. Yeah, and I think it's interesting, you know, with the POSIX file system, many times you're limited to in some practical sense to how large a file you can deal with, right? This NetSep3 files, even with the entire thing aggregated, it's not that big. It's a few hundred megabytes. But you can imagine circumstances where if you did this aggregation, you would wind up files in the terabyte size, and that can be a little challenging to deal with on a POSIX file system. Since with HSDS, with its sharded format, there's really no limit to how large the file can be, right? So if I have, 20 years of daily data where each data set is 100 gigabytes, that's fine, right? I can just aggregate the whole thing to one petabyte size file.
Well, but you can use now all tricks, HDF5 tricks, right? External links and VDSs to combine data and not to rewrite, because it's really silly to rewrite. But you can create wrapper file that provides you with aggregation, because you still will not be reading terabyte of data at once, right? But you will have a wrapper file that can point, for example, aggregated data set, it's VDS that points to the right files and even to right locations in those data sets.
Right. Yeah, actually, virtual data sets are a feature we don't have yet in HSDS. So we had a user who was looking for this exact kind of example where they had a set of NetCDF files and they wanted to clump them together. It was much easier to do this than to implement VDS in HSDS.
Actually, it's probably 10 lines of code, especially with H5Py. But
no, I mean to add the VDS feature to HSDS would be fairly challenging, right?
I was talking about POSIX system, because for you it's really it does matter, right? It's just replacing JSON files, right? Yeah.
There's another question, John. Ray.
Oh, hi, John.
Hey.
So this is we're hoping to reactivate that work we did some years ago on using HSDS with NextPy, and we have started using virtual data sets quite a lot for doing exactly what you're saying, aggregating lots of large files together. So is this part of the H5PyD API? Could we actually sort of mimic the virtual data set using the API within, using this aggregation feature?
Right. So I did all this work in this last week, and it didn't actually touch H5PyD in terms of the functions, right? This is all code I added to the hsload script.
Right.
So
we could probably submit it as a sort of a job or something, as a sub process to create the load and then read the. Okay, yeah, that looks very nice.
Yeah, and also I remember Nexus is one of these things where I think initially we were looking at loading Nexus data on HSDS. It was a bit of a challenge because clients would typically want to read a bunch of attributes and such, and that would take a lot of round trips to the server. And as I was mentioning here, now up to some limit of like 2 megabytes, I think, that when you do the initial load, all the metadata comes in that first open. So in the REST layer, when you do that GET call, you get not just information about the root group, but all the subgroups of that and all the attributes. So here, when I actually are reading attributes, it doesn't require any time because there's no server access there.
So you're copying the entire tree of the
yes, right,
in a single call. Okay, that's great, because actually we've done the opposite, and we've started caching when we load the files now. We actually do just load the top layer in NextPy, and then as people put in calls to other layers, then they get loaded. But we can turn that on or off. So what you're saying is we should turn that off then for HSDS and
right, yeah. There is an option to not do this, right? So if you say I think it's use cache, it's false. I think we do this. Oops. Yeah. So now if we go through here, it all looks same. Looks same. But if I do this, you see it actually took 6 milliseconds to do that call versus microseconds, right? Because it actually is going to the server to get that attribute and come back.
Yeah. Okay, well, I'll try and get up to speed on this soon. Thanks.
Okay, awesome. Okay, well, does anyone have questions about HSDS or HDF5?
Just one comment. If we were talking about when you're loading, you're reading the real HDF file, right? And I believe Alexandra also showed that page deallocation, if file is written with page deallocation, this is much faster because all metadata will be in a few metadata pages that are loaded. So you do not need to go back and forth. So we can tell users to use these features as much as possible.
All right. Cool. So I guess there's no other questions. We can.
There is another question, John.
Oh, right. Hey, Marianne.
Hi, I have a question, and I'm very new to HDF5. So I take it that Ask the Doctor, there's no prerequisite I have to know very much.
No, we allow anyone to join.
So I'm working with a lot of data from Wafer Pro in the semiconductor industry, and I just mentioned that you may have encountered it. And I'm tasked with developing a GUI for users so that they could create a canvas and have some persistent plots of various types from within the HDF5 data set. They're generally just X versus Y plots. They may want to transform the data just by applying a transform to one column. And my questions are in kind of 2 areas. One is just very high level. I don't like to invent the wheel all over again if somebody else already did it. And so I've been looking around. I have HDF5 viewer, but that doesn't provide enough features for our users. They want to be able to label axes and apply those transforms and have the persistent plots. So does this match any, is it enough to even understand what I'm talking about? And does that match any application that you see that's already been written?
So in your application, you want not just to be reading HDF data, but you want to enable users to modify data or certain aspects of the data.
Just to view the modified data, they don't have to write it out.
Oh,
but
it doesn't
view it.
update the source file.
It doesn't have to, yeah.
Yeah, I'm not aware of anything exactly like that. Gerd or Elena, have you?
Well, I think any plotting package, and I believe last time, it was a long time ago, GNU plot, even if it still exists, it had ability to read data, MATLAB can read, then packages like that are, if you can do it in Python and use H5Py to read data, there are definitely viewers there. So yes, it's worth looking around for data annotation, for visualization of the data, because when you read it, you can use whatever interface the tool provides.
Yeah, so
nothing.
it is Python that I was planning to use, and Matplotlib was the one that was kind of winning for.
Yeah.
So Marion, I mean, can your users just be using Jupyter, or do you need to have like a web app or desktop app for them to use?
So I work for Keysight Technologies, and we actually want the app to be something they launch from within our tool that runs on Python, but uses PySide to probably use the GUI, unless there was something already made. And if there was, then I would, if it was on GitHub, I would probably just see if I could take it and, do a fork and adapt it or something like that.
Since I'm on the call, can I chip in?
Sure.
I mean, I coincidentally, actually, Laurie has asked if I could give a presentation next, is it a week on tomorrow, isn't that right?
The 16th, yeah.
On it's a program called NextPy, which John knows about already, but and although it's dedicated to X-ray and neutron scattering, it will actually read nearly all generic HDF files and does have a sort of GUI interface to Matplotlib. I mean, it allows you to, load the files in a tree and then plot them in a screen. So perhaps if you're able to check out that talk, you can decide whether you like it. Yeah, and I see somebody else has posted that there are now web tools available, like the last talk was on that. Anyway, so there are tools out there, but you have to decide which one you like or not.
Yeah, the link that I just posted for this web-based viewer, it's not intended, it depends on how large your files are. I mean, I remember loading like a 300 megabyte file. That's probably fine. I haven't tried a terabyte file or something like that. The trick here is it looks like it's running on the web, but it uses as part of the HTML5 standard, there's a file system in browsers. And so it really just copies the file from your local machine into that file system on the browser, so the data actually never leaves your machine. It just downloads. There's a so-called WebAssembly or H5WASM that is downloaded from the site, and then the file is copied into the browser file system, and then the standard HDF5 library runs in that WebAssembly. And you can use this H5Web there if you like it. There are also Python bindings for it, so you can include it in your Jupyter notebooks and so forth. It's developed by the ESRF, the European Synchrotron, and it's a cool thing. Yeah, exactly. This is the page here.
Yeah, I'm gonna put that in the chat. And I think this might be really useful because it's not just a complete application, it's a toolkit of sorts, right? A set of React components that you can put together any which way you want.
Yeah, and it has visualization capabilities, so it can do like heat maps and histograms and things like that. It is a little focused on, I mean, there's Nexus here, so the data that you find in synchrotrons and light sources and so forth, but it understands sort of general purpose, call it that, HDF5, and yeah, you can definitely see the group structure, see a grid view for data sets, and then make selections on that. And
it supports HSDS.
it supports HSDS, that's right.
That's something I'll have to add. I put in the link to the documentation for NextPy if you can install it from PyPy if you want to try it out.
Yeah, yeah, great.
I'll try these out. This looks like, I don't know, definitely worth looking at, learning. So then I have a real specific question too, where I've been looking for some examples because I'm so new with working at the HDF5, and the area where I have trouble finding good examples is as I go through and search the HDF5 hierarchy using visit items, I think is what I've been using. And then I have a data set and I want to be able to do things with it, like get the data out of it and get the attributes. And I thought that's what I wanted to do anyway, so that I could put it in like a NumPy array or something like that and plot it with Matplotlib. But I have such a hard time finding out how to grab the object that's the data set when I'm traversing that way. And I've looked at so many examples. I think on, well, H5Py, I couldn't find anything that went through the hierarchy. And when I look on, say, like Stack Overflow or something, everything is like one author. Oh, great. Is there a tutorial for this? That would be wonderful, because I just looked and I think I have an object, and then I try to get attributes out of it and nothing.
Okay, so I want to do a plug now for HDF Lab. So I still sharing my screen, right? So HDF Lab is a free web-based Jupyter lab that you can sign up for and get your own account. And it's a good kind of playground for trying out things. And as part of that, when you sign in HDF Lab, you'll find this folder, HDF Lab examples, or just / examples. And under that, there's a folder called tutorial. And the tutorials are a set of Python notebooks that walk you through different aspects of HDF5. So for example, this one, and it works with either HDF5 library or HSDS. You'll get the same experience either way. So for example, over here, you create a file, has an ID. You can create new groups. You can enter IDs. We can list the groups. We can create a data set. And the nice thing about Jupyter is that you can change things around and see how that affects. And if you mess it up, just go back to the original version. That's okay. Here I create a subgroup. Create a soft link. External links. And then here we do this visit thing, right? So I define a function print name that just prints the name. And you get G2, G2, G1.1, G1, G set1, so on. So that's should get you started, I think, on the basics. So there's like a notebook on doing attributes, a notebook on compression, notebooks on plotting and types, and so on. So it might be useful just to run through these and get an overall sense of how HDF works.
Cool, thanks. I'll look at it. There's always next week.
Okay. Yeah, come back next week and tell us how it went.
Okay.
And if there's things that need to be improving, we'll be happy to work on those.
Thanks.
And if you have questions, have you asked on the forum?
Yeah, I did ask about the general question about an app, like what I'm trying to develop, and I don't think I saw anything posted yet.
Oh.
But it's been a few days since I checked. I know I didn't get an email. I kept checking back and there was nothing. So it's possible I missed something though.
There is some example on portal. Unfortunately, I checked. There is no example what you're looking for, but they will give you an idea. There are some Python examples too. So if you look, I just posted the link to the portal, HDF Group portal.
Okay, great. Thanks. That's all I have for questions. I'll look at all this. Oh yeah, this
H5Py website also has some good examples, I think. Documentation, H5Py.
I struggled with them.
Well,
I feel like for one thing, I have to work on Windows now, and my whole Windows is so messed up from trying to install the H5Py on their list. Yeah. Because they just stay at the top level. They don't like traverse the hierarchy. What I found, the examples, and so then I can do this like visit items, and I can get something like node.name. But then if I treat that as an object, it's not.
Yeah, it's right here, right? This, I think there's a visit where you get the name and the object.
Visit items, I think it can give name and a node, and then I thought the node would be the object, but then if I took the node and then I looked for like this shape or something, it didn't give me anything.
You probably have to put brackets with parentheses in order to actually extract the array from H5Py. You know.
So like this.
Because the H5Py objects are references to the address in the H5Py file, but if you actually want the data, you then got to access the slab you want. So, I mean, I'm not explaining this very well, but you know, I can put it in here. You'd have to do. I'll put it into the chat. You have to do something like that to the next H5Py object in order to extract the data from that object.
So I tried just the square brackets, but I didn't have the parentheses inside it. So for this, where he typed name comma object, and then that object, if I've chosen to go through recursively and only select data sets, then that should be a data set.
Yeah.
And then if I put object inside your parentheses there, A of square bracket of parenthesis of object, that would be.
I mean, the H5Py convention is if A refers to a data set, then putting those square brackets and parentheses will extract the entire array or string, depending on what it is. So yeah, presumably.
There is low-level example for visit. If you look at visit, there will be H5Py example visit on that portal side that shows how to do it.
I tried to follow it. I just I didn't seem to be getting object out of it that represented the data set. So there's
low-level API, not a high-level API in H5Py. It's low-level.
Okay.
But see, this seems to work, right? So you do visit items, and I in visit items, I'll get both groups and data sets. So I do a check here. Do I actually have a data set? And if I do, I do what Ray's saying is object bracket paren bracket. And here I see I got data 42.
So how do you actually get the data value, or is that the
is the data 42?
That is the data. Okay, just one. It's like one dimensional.
It's got a shape.
But it should work for multiple.
Yeah. All right, that's probably the answer I've been looking for. This looks very promising. Thank you.
I'll put in another plug. I mean, the Nexus format does what John does in HSDF, I think, which is to download the whole tree, and then you can just access the object. So it's sort of one. It uses H5Py, but it's just a abstraction layer on top that gives you access to the things as if they were NumPy arrays. So you load the tree, and everything is a NumPy array. Yeah.
And that doesn't, like, if you have really big data, it doesn't just grind things to a halt.
So it loads the, well, as I was saying to you actually earlier, we now cache, if it's a really large tree, it only caches the top layers, but it only loads small data sets. So the large data sets will, it'll just have a pointer to the data set. And then if you reference a slab using one of these, square bracket notation, then it will extract that data. So it doesn't, yeah, I mean, we deal with terabytes of data and we can load the file in, in fractions of a second. But as we were saying earlier, you only ever plot some small subset of the data, for instance, so it'll, so large data sets are not loaded until you actually ask for a slab.
Right. Yeah. So I think, HDF5 is a little tricky. If like in this, where I'm taking a data set and I want to access all the data, if I have a terabyte sized data set, that'll be problematic. On the other hand, if I try to read every element in a loop, that'll be really slow too, right? So it requires a bit of balance. There's one trick where you can say, so like here I have data, you can say, data with some kind of stride. How does that work? So here I'm selecting every 10th element in both X and Y dimensions. So you're kind of reducing the amount of data by a factor of 100. You don't see all the data, but you get a kind of representative sampling of the data.
John, the type of that data is basically an H5Pi data set, is that right?
Yes.
Okay, and then so you're accessing slabs in exactly the same way as
Right. H5Pi-D was meant to mimic as closely as possible H5Pi.
Yeah.
So a lot of times, like in these tutorial examples, you can switch this define from 0 to 1 to use H5Pi or H5Pi-D, and everything else works exactly the same.
Right. So actually, it is much more a one-to-one mapping of core signatures than it was probably when I was looking at it earlier. Is that right? Because
right. That's slowly maybe filled in some of the spots where we're missing features in H5Pi.
Okay, no, I've definitely got to try it again now. Then. Yeah.
Awesome. All right. Well, if no one else has any questions or comments, I guess we'll call it a day. Thanks everyone for attending.
Thank you.
Thank you.
Session.
Thank you.
Bye, guys.
Bye.
Mhm.
Thanks. Bye.